Alright guys, so we're going to do our Unit 1 review here. This is all over a little intro into functions. The test is going to cover identifying functions, performing the vertical line test, parent functions, I'll go over what I'm expecting for that in a little bit, and evaluating functions, either through substitution or graphically. Okay. First thing we're going to look at is identifying functions using coordinates. So that's using the x, y points. All right. Just remember that a function has only one output for each input. All right. Each of these coordinates is written x, y, or input, output. For coordinates, you need to check each first number. You can see I've highlighted each first number in this first set here. Okay. What you'll notice is each one of them is different. If they are all different, then you can immediately say that this is a function. Okay. However, if you start to look through the first numbers and you notice repeats, okay, check to see their outputs. If they have the same output, if these both outputted 7, this could still be a function. However, since we have -7 popping out of 4 and -7 popping out of 7 in two different points, this is not a function. This input, -7, has more than one output. Okay? The same process is used when we're talking about tables as well. However, it's organized a little differently. So you're going to want to look at the left column. It'll usually be labeled either X or input, sometimes even be labeled domain. Okay, and you're going to want to see each of those X's being different numbers again. Okay, you can see each one of these numbers over here is different. However, once we get over here, we see that we have two repeating -3s. These -3s, we need to come over and we need to check their outputs, which are right here in the right column. And now that we see that they're different, we know that this is not a function. Okay? So to reiterate about identifying functions, check the x values, whether that's in the left column or the first number of coordinates. If you do not see any repeats, you immediately know it's not a function. If you do see repeats, check the outputs that they're different. If they are different, then it is not a function. Okay? There is one more way we use to identify functions, and that's the vertical line test. Okay? So if a vertical line intersects a curve or a graph on the xy plane more than once, it does not represent a function. So you can see in this first graph, there's vertical lines drawn all throughout this. And this middle vertical line hits it 1, 2, 3 times. Okay? As soon as one vertical line fails the function in one spot, that is no longer a function. Okay? So if this was the only point or the only line that intersected more than one point, that would immediately make it not a function. Whereas if we look over here, every single one of these vertical lines is intersecting this downsloping line only once. Okay? And if you have vertical lines intersecting only once, you do have a function. Okay? More than once, not a function. Only once, it is a function. These vertical lines represent our inputs. Okay? And if they only hit once, that means we only have one output for each input. Okay? Now, what I'm asking you guys to do for parent functions, okay, is not to simply be able to know what the picture is of them. If you do, that's great. But what I want you guys to be able to do is to open up Desmos during the test and be able to type these in. Okay, so we have the absolute value equation, which is y equals the absolute value of x. These little bars are the key right above the enter. Right? I believe you do have to press shift and then that button to get those lines. Or you can also type out A, B, S and then put your equation, or your x in this case, inside those parentheses. Okay? For the quadratic, which is y equals x squared, you're going to need to use shift 6 to make an exponent and then a right arrow to move back down. You may not have to worry about the right arrow because you're only putting one exponent in there and not going to be expanding it any further. But remember that exponent, you got to press Shift 6. It looks like a little caret key. Okay. For the square root symbol, y equals the square root of x, you need to type out the letters S, Q, R, T. Okay, those 4 letters, and as soon as you press T, it'll immediately turn into a square root symbol, and you can type X underneath it. If you ever want to get out from underneath the square root symbol, you just press the right arrow key like you do for exponents. Okay, and then finally there's exponential growth, which is done the same way as quadratics, okay, with the Shift 6 key to make the exponent. You just need to type 2 down low and make x your exponent. You just need to switch your x and your 2 around. Okay, so make sure you guys watch my video if you need a little bit more of a refresher, or just get on Desmos and try typing these things in. Okay, if you can type them in and you can make the graph, you will be perfect for the test. All right. Last thing we're going to do is evaluating functions. So there was 2 ways that we could evaluate functions, either by substitution or graphically. With substitution, okay, we need to note that each one of these is going to be written in function notation, all right? That's where y, usually these are written y equals some equation with x, is going to be written as f parentheses x, or f of x, okay? F is just the name of the function, and x is the input that we are using. In order to evaluate, we're going to be using function notation. That way, when we say we have a function g of x, we could simply write g parentheses 2, or g evaluated at 2, and that would be representing the output of that function g with the input 2. So if we had some kind of function g, some equation, we could take the number 2, and this would represent what number would pop out when we put in 2. Okay? How to do that? You're going to take the equation, so you can look down here. I have an equation, f of x equals x squared plus 3x plus 4, and each x you're going to replace with parentheses. Okay? After you've rewritten the equation with parentheses, and notice even this x, you're just going to leave those parentheses there. Place the input number, so the number that they want, inside each parentheses. So I did that here. I rewrote this with parentheses for the x's. Notice everything else is still the same. Squared plus 3 plus 4, all the same. Okay? And then I took the input and I plugged it in. After that, it's just order of operations. So I squared my negative 2. And remember, because of those parentheses, and since we're doing negative 2 times negative 2, it's going to make a positive 4. Okay? Any negative squared always makes a positive. And then I did positive 3 times negative 2 to get a negative 6. And then the plus 4 just stayed the same. Then I just added it all together. Got myself a 2 as my final answer. Okay? So again, just rewrite the equation with the parentheses. After you've rewritten the equation with the parentheses, then put your input in those spaces. Okay? So the other way we're evaluating functions is maybe a little bit easier. So they gave us just graphs of the functions without the equations. Okay, you could see this would be kind of our quadratic equation here. But what they want is they're either going to give us an input or an output, and they want us to find the other part of it. Okay, so in this first case here, they gave us the input of 2 for this function g. This blue line is this function g. So since 2 is inside the parentheses, I went down to the bottom and found where 2 was. You can see it highlighted in yellow there on the graph, and then just trace that line back up until I hit the graph. Once I hit the graph, I just saw where I was on the y-axis. I even wrote down the point that this occurred at. So when I have an input of 2, my output was 7. Therefore, g of 2, or the output at 2, equals 7. Right? Sometimes they'll give you the output. That's when they write the function name with the input, f of x in this case, and then they'll write equals 4. Okay, so if you see a number on the other side of the equal sign, you need to make sure you're going to your y-axis. Inside the equal sign, x, outside, y. Okay, so here I did the same thing. I went to my 4, this time on the y-axis, and I just traced the horizontal line in this case until I hit my graph. Once I hit my graph, I saw where I was on the x-axis and wrote down that point. I was at point 3, 4. So, for the output of 4, I need an input of 3. Or in other words, x equals 3 when f of x equals 4. Okay? If you guys need any other examples or help with any of this stuff, please send me an email or hit me up on Remind or any other way. Just get in contact with me and let me know you need some help. Okay? Good luck on the test next week, and I'm sure you guys will do just fine. All right? Have a good weekend.